Hello, everyone. Thank you one more time to be here in this edition of Carla conference. For me, it's a pleasure to introduce Robert Herschel. Robert is researcher and professor of the University of Indiana. He is the director of research software and solutions in the research technology division. He holds master's degrees in computer science from Technische Universität Dresden in Germany, and has a strong background in high-performance computing. Henschel, on the other hand, leads teams how to utilize IU's advanced civil infrastructure to provide scientific application to researchers at Indiana University and national partners. He is the responsibility of the Advanced Biomedical IT Core that provides support for computational research to the IU School of Medicine. And also, Henschel is one of the partners, scientific partners of Sendio. This technical talk is about the Sendio solution. Sendio is one of the most important and most oldest company in open source at the world. And this year is the first year that Sendio had with us here in Carla 2020. Thank you very much, Robert. Please, your time. Thank you.
Thank you so much for the introduction. Okay, I assume you can all see my screen here, so let me get going. I'm not a professor at Indiana University, just to be clear. I'm a director in the IT organization, and the rest of the introduction was correct. It is my role to provide support and applications for our supercomputing systems at the university and make them available to all of our researchers, faculty, and staff, and students as well. I'm going to talk a little bit about a project that we call the Research Desktop, which is one way how we make our supercomputer systems easier, make them available in an easier way for new users. I'll just talk a little bit about IU and what we do when it comes to supercomputing at IU, and then introduce the concept of the Research Desktop, and then give a little bit of an overview of how we implemented it at IU. So IU is it's Indiana University, not the University of Indiana. Indiana University is a large public university in the state of Indiana in the US. It's basically in the Midwest, a couple of hours driving south of Chicago, if you're familiar with where Chicago is. The university has two large campuses, one in Indianapolis and one in Bloomington. And each of those campuses has about 50,000 students. So it is a fairly large university with about a history of about 200 years. It is when it comes to classification, it is an R1 university, meaning there is a lot of research going on. So our systems are there both for the education of students and for research of faculty members. And we have a fairly large central IT organization that supports all those researchers. From a supercomputing side, we have a number of small to medium scale systems. Our biggest system currently is a Cray system with about 1,000 compute nodes for a total capacity of a petaflop, all of that in CPUs. And then we have a number of smaller systems for high throughput computing, and then also a GPU cluster. Our new system that will come online later this year is GPU based, about 6 petaflop in the new Cray Shasta architecture with AMD Rome processors and NVIDIA A100 GPUs. We also run a system for the National Sciences Foundation in the US for a national audience that is allocated through Exceed, which is a federation of HPC centers in the US, called Jetstream, and that is a cloud system where researchers can use cloud technology to run their jobs. So let me introduce the concept of the Research Desktop. One thing that we're faced with at IU is that we're trying to make our supercomputing systems as generally available and as useful to a lot of different students in a lot of different disciplines as we can. So the university has promoted that mode of access for a number of years, and we are really evaluated by how many different users from how many different fields of science can we make those systems available to. So when a researcher looks at the IT infrastructure at the university, they immediately have a number of different options, right? So they can compute on their own desktop or laptop. They can do this on an iPad or Chromebook to a very limited extent. Some departments have their own servers. We have a Windows environment called IU Anywhere, which is basically a Citrix farm where people can run Windows applications. We have a VM-based infrastructure as a private cloud system, and then we have the HPC systems and Jetstream. So all of those systems are available free of charge to a large extent, free of charge to our users. So it's kind of hard for our users to make to decide where to run their workloads. At the same time, a lot of those systems are Windows-based, or at the very least offer a very graphical user interface to getting your computation done. So when you look at the history of supercomputing, right? Supercomputers have evolved over the last 50 years from machines that fill an entire room to very, very powerful machines that can fit into a single rack. What unfortunately has not really evolved is how you interact with supercomputers. So yes, today we have some science gateways, we have some applications that will make use of supercomputing systems in the background, but when new students or new users of supercomputing systems get started, they are normally confronted with an SSH shell, right? And in the past, that was very easy because text mode was also how you interacted with your own personal computer. But nowadays, students and also younger researchers are growing up in an environment where a command line is not really a thing anymore, right? You are living on a Windows desktop or a Mac OS desktop, and icons and drag and drop are the way how you interact with a computer. So telling new users that, okay, here's this command line environment, go ahead, make productive use of the system, is not necessarily a great start. So when you compare this, for example, to desktop computing, right? So in the past, desktop computing very much looked like supercomputing in the sense that you had a text mode environment and then you had some ASCII art interface, for example, for word processing. And then a graphical shell was developed. And nowadays, I think we're running Microsoft Word in the browser, right? And that goes for a lot of other applications like Google Spreadsheets and the Google suite of products as well. So there was a real evolution from on desktop computing that just hasn't really happened in the supercomputing world. So the users that are coming into the systems today are coming with a whole new set of skills than they came 10 or 20 years ago. So it is important for us to provide a platform that takes those users and helps them along from an environment that looks very different. At the same time, as an HPC center, we're somewhat competing with cloud providers. And I have to say, cloud providers do an excellent job when it comes to public relations and advertising. So they have really pushed us to offer a more convenient environment. So, and I think that gets me to the third point. We are now tasked with not just providing an efficient environment where people can use our hardware resources in an efficient way without wasting CPU cycles, but at the same time, we need to provide a somewhat convenient environment that users don't have to completely start from scratch learning how to interact with that environment. So there is a certain trade-off between what new users really want and what we offer them. And the concept that we've really embraced here is basically a remote desktop solution based on Linux. which looks very similar to your Mac OS or your Windows desktop, and where you can get started, and then you can learn more and more about the environment. You can grow into a command line environment. You can grow into a batch-driven environment. But you can start with something that looks very similar to your desktop environment. So let's take a look at the research desktop. Basically, this is the way how traditional access to supercomputers works. You have a laptop, you have a desktop, or you have your own machine. You SSH into a login node on a cluster. You prepare your jobs, right, and you submit them to a batch system, Slurm, PBS Pro, batch systems like those. And then they run on a compute node in the background, and then you get an email at some point saying, hey, your job's done. Please look at the results. I think this works very well. It's a very efficient way of using the system. People who have grown up with this metaphor, no problem. I personally think everybody should use the system through a command shell, but to get new users into that mode, this is what we did in parallel. Basically, you can still come from your laptop, or you can come from an iPad or Chromebook. You come to a system that looks like a desktop. You can run applications right on those nodes with point and click. So you can double click on MATLAB, for example, or Console Multiphysics, or RStudio, or some of the other graphical applications. And they are running on a system with 256, 512 gigabytes of memory, 32, 48 cores. So they are running on a powerful machine, and you can get work done right on those nodes. At the same time, you can also submit your workload to the batch system. So you basically, you can start off running locally, and then as you grow more, as you need more resources, you can figure out how to use the batch system. But you do not immediately have to go to a command line environment. You do not immediately have to go to a batch-driven environment. So what does the remote desktop look like? Again, the concept of the research desktop is basically a remote desktop. You can get to it from a browser, any HTML5 capable browser, for example, on Windows, Linux, Mac OS, iOS, on iPhone and iPad, Android tablets, Android phones, can all get to this. Is it super convenient to interact with a desktop from your phone? Probably not. But is it enough to check in how a computation is going that you've started a while ago? Absolutely possible. So, and there are native clients available from Sandio as well for opening a connection from macOS, Windows, and Linux with a native application. So this is what the desktop looks like. We've customized it a little bit. We're using Mate as the windowing environment. So everything that people know from Windows or Mac OS is right there. You have folder icons that you can double click on, file browser will open, and you can browse the files in your home directory or in your scratch space on Lustre or GPFS or Panasas. So basically anything that you are familiar with from your desktop is here as well. You have icons for applications that you can double click and the application will open right up. We've also installed some convenience applications like Firefox. So normally we would not recommend people browse the web from a supercomputer, but sometimes you want to download an application, or you want to download a piece of code from a website. Having a web browser available is very useful in those circumstances. So we started with the concept in 2015. We've started with the free evaluation license that Sandio offers, which at that point in time allowed you to run up to 10 concurrent connections, which is very nice. And we did a competitive evaluation of what software to use, and in the end settled on ThinLinc from Sandio because of the open source history of the company. And we've seen that the company was involved in some open source projects and also generally has contributed very well to the open source community. So we've started evaluating ThinLinc, and then in the middle of 2015, made it available to a number of beta users. We ran it as a closed beta, meaning by invitation only for 6 months, and then as an open beta for 2 years, and made it generally available as a service in 2017. That is a very long time, but we basically took our time there to make sure that we've tuned the service to really be useful for new users, right? The service was immediately useful for power users, but we wanted to make sure that we have the desktop right, we have the support mechanism right, so that we can really make the service available to new users in HPC systems. And then we, first of all, called it Karst Desktop, which was one of our supercomputers was called Karst, and we basically advertised it as the desktop version of the supercomputer. To make it more general, we transitioned it to calling it the research desktop 3 years after we started. The system has undergone a number of changes, so it is really a very successful service at the university. We've grown from 10 dedicated servers to 26. We've done an upgrade from Red Hat 6 to Red Hat 7. We'll soon do an upgrade to Red Hat 8. We've also gone from the really ancient GNOME 2 version to a very similar looking but nicely maintained version of Mate. We've done some custom development on the solution as well around rclone for cloud access. So when you look at rclone is a command line application that can interface with cloud storage solutions like Google Drive, AWS S3 buckets, Box, Dropbox, a number of online cloud storage systems. And by making that available, users can configure to some extent their own access to cloud storage systems, because this is what they do on their desktop, right? If you have your files in a cloud storage solution, then you also want to get to it from the research desktop. And then we've used an open source product called Sanity to build a few graphical tools that help people navigate the system. So Sanity allows you to run graphical dialogues from shell scripts, which allows you to easily ask a user a question, for example, or display a dialogue, which is much, much better than just doing that in a command line way. So, and then the biggest change was some time ago, we introduced the web interface. So when we started with the service in 2015, the web interface was available, but we chose not to make it available to our users. But we've in the meantime changed our mind because we have more and more users who are coming to us from iPads or Chromebooks. And currently Sentio does not offer an application for iOS or Android. So for those users to get to the research desktop, we advocated they use the HTML5 version of accessing the service. So one thing that I really want to stress is that we really customized the way that users experience the system, and we've really spent some time in customizing the desktop and the support infrastructure as well, so that it really feels as close to a desktop environment as you can make it. So we allow for long-running sessions, for example. So when you connect to the system, when you're on campus, and then you go home in the evening, you can disconnect from the session will continue running. So if you have MATLAB, for example, open and you're doing computation, you can disconnect from it, reconnect when you come home, and the MATLAB session will still be running. It will have made progress in the calculation in the meantime. We allow those sessions to run for up to 7 days. So users have to connect to their session every 7 days. And the idea here is clearly to give you an environment that you can run in for a long, long time. So we do maintenance on our machine once a month or once every 2 months. And we have a large number of users who have their same session open basically for 30 days or 60 days in the same environment. So you customize the environment once, and then you just use it, which is hugely successful because users can do this on the login nodes of the HPC systems with Screen, for example, but teaching new users how to use Screen is a really hard task. However, telling users how to close an application and reopen it, and it automatically reconnects to the existing session is very, very easy. So some of the use cases for the system, of course, running mathematical and statistical applications like SAS, Stata, SPSS, running graphical applications in the HPC domain. Think of the Vampire performance analysis tools, a linear map, total view debuggers. We're offering visualization tools like VMD, ParaView, not GPU accelerated right now, but doing just plain visualization. Client-server applications like COMSOL Multiphysics or the Schrödinger suite of products. Easy access for compilers. We have a number of mathematics professors who teach Fortran in their class, and they just want a system where they can go to, write a Fortran application, and immediately compile it with, for example, GNU Fortran, without having to tell users how to install a Fortran compiler on their laptops. And then a big part is facilitating collaboration. So, for example, we have a research team around Dr. Franco Pistilli, who has a number of collaborators all over the world in Japan, South America, and Europe, and they will all connect to the same research desktop at IU, and then basically find the very same environment. So sharing a data set does not mean you have to transfer a data set across the Atlantic to the Pacific here, but you can basically leave the data set on the machine where the research desktop runs and everybody can see it, which makes collaboration much easier. They all can use the same application, same scripts in the same environment. This is just a slide with all the icons of some of the applications that we run. We offer Jupyter notebooks, we offer RStudio services, and I think those are one of the more popular applications that are running on the research desktop. So just as to finish this up and allow time for questions, providing an interactive environment, however, requires more babysitting for users. Users fundamentally have higher expectations towards a interactive environment than they have towards a batch-driven HPC system. So if we make something available that feels like a desktop, we also need to come up with a support infrastructure that allows people to get quick answers around those and to monitor the system much better than we monitor the standard HPC system. So here's just, we're doing monitoring on licenses, users, and number of sessions, which is a nice overall growth. You can also see some of our maintenance days, but it's just important for us to know how many licenses are in use, what's the total number of sessions on a daily basis, so we can see if the system needs more resources. We have specific charts in place where we look at how many batch jobs are submitted from the research desktop. So how do we help users grow into productive HPC users with batch jobs? So the idea clearly is to take users on the research desktop and help them move along into a batch-driven system, and a few others. So I think as a summary, I think standing up the research desktop was a really interesting project for us. It has helped us reach new users and make the HPC systems more interesting for students and faculty members that don't have a background in high-performance computing. And in general, working with Sandio was a great experience. They are nice to interact with. Even for us, dealing with a company in Sweden is 6 time zone. There's a 6-hour time difference between us and Sweden, but so far we've had no issues on the support side, and they really understand how the university environment works when it comes to pricing and helping users really use their service, customizing the service. So with this, thanks so much for your time. Time for questions.
Thank you very much, Robert. So we are open for the questions. We have one here from the social network. So what is the main opposition of concerns from the users to the use of this kind of desktop solutions?
The main concern from users?
Yes.
So the main concern that users had was actually to use the batch-driven system, not necessarily the desktop one. So I think we had a lot of users that had trouble using the standard way of how we make the HPC systems available. We have not gotten many concerns about the desktop environment. One thing that certainly is one concern for us is that we're offering it in a shared way, right? So we have a lot of users who share the same node. So we have a number of policies in place that protect one user from the other. But for example, if a node dies because of a hardware defect, then 10 users lose their desktop. And then we will send an email and say, we're very sorry that you lost your desktop, but here's what you can do to recover. So I think that's the major concern.
Okay. There are another one. What about the performance problems due to the large scale platform? For example, in more than 2 campus or 2 geographic sites behind them.
So I assume the question asks for the graphical performance, right? If I have a graphical application for multiple campuses, how does this affect performance? I have seen no performance issues specifically from multiple campuses. I've used the solution personally from Europe and also from Asia. And yes, I mean, you have sometimes you have 50, 100 millisecond latency, but if you are within the global research network, you hardly notice. So for me, it is the convenience of having one open environment that I can take with me wherever I go vastly outweighs the performance issues. And again, for us, from a graphical point of view, things like MATLAB or COMSOL multiphysics or even Firefox as a browser run very well in this solution. The solution uses compressed SSH and then VNC as the protocol in a compressed SSH session. So that works very well, even over long distances.
Okay, thank you. The other one, though, so that is the research desktop a free software for HPC system based on open source software like a Slurm scheduler?
Sorry, say that again.
Is the research desktop a free software for HPC system based on open source software like Slurm, for example?
No, the research desktop itself, we have implemented it using ThinLinc from Sendio. That is not a free software. You could implement this yourself using VNC and SSH, which are both free software and open source. But there is a lot of infrastructure in the Sendio product to monitor users, figure out how many sessions are open, provide monitoring, that we decided to rather go with a product from Sendio to get us a little bit of the convenience for the administrators and for the users as well. Okay. And it's fairly reasonably priced, I have to say. One of the big reasons we went with Sendio is because pricing was very reasonable.
Okay, the other one. Why not the use of GPUs today?
So we are currently not using GPUs in the ThinLinc and research desktop environment. However, there's a number of other universities that use the ThinLinc product with both remote GPUs and GPUs in the nodes. You can do remote OpenGL, you can do OpenGL on the same nodes, and this will work very well. We don't have GPUs in our nodes, but that is certainly something that we're looking for in the future.
Okay. Another one from the social network. So how we can be part of the contributors for Sendio?
Sorry, say that again.
How we can be part of the contributors, of the people that contribute for Sendio?
You can, if you have suggestions or you have code contributions, by all means, you should just get in contact with Sendio. There is a, we have not contributed to the product ourselves, other than bug reports, which were then fixed by Sendio. But Sendio runs a public bug tracker, and you can see their development on that system, and I'm pretty sure they have an email address and a contact form as well.
Okay, so I think that this is all of the question. Okay, so thank you very much, Robert, for your presentation, your speech. I invite to the next to the next demonstration of send you. Send you in the program the slots to have this presentation. So thank you one more time, Robert. And please stay here in the channel of the conference via Zoom or via YouTube or the Facebook channel. Thank you very much.